Hello guys, welcome to my YouTube channel. In today's video we're going to talk about our first algorithm that is known as KNN, and full form is K nearest neighborhood. This is the first algorithm we're going to discuss in our playlist. So we will discuss from the starting and we'll try to cover and connect all the concept whatever we study up to this time. Okay, so let's start this algorithm by defining what is a KNN. First, let's discuss what is the intuition behind the K nearest neighborhood. So, data set, we have a two class label. One class label is defined by cross and one is defined by small o. Now I have a query point P and I want to know this query point P is belong to which class label. Either it goes to class level cross or either it goes to class level 0. So that is my question. So if you can see, this is the point P and I want to know it belong to which class in my, and I want to know it belong to which class. So to know this query point belong to which class, what we need to do, we need to calculate the distance from each point in dataset. Then after calculating the distance of each point from this dataset, you going to select the neighbors based on k value, based on the k value. Then let us suppose here in this example you tell k is equal to 3. So once you calculate the distance of every point from this query point, then you have to be select the three nearest neighborhood. So what is the three nearest neighborhood to this point? I can see this is the three neighbors of this query point P. Okay, after that you're going to do the majority what to know the class level. So if you see, for star is 1 and for O is 2. So what is the majority? O is a majority for k is equal to 3. So I can see this P point belongs to my O class. Okay, so that is what the intuition behind this algorithm. So to explain it more easily, let me take another example. Let's see in this slide we have two data set. One is for the cat and one is for the dog, and I have this image and I want to know this image is belong to either cat, either this image is a cat or this image is a dog. So what they do, they calculate the distance of this image from every cat and every dog. Then based on the nearest neighborhood, means based on the nearest value, integer value of a k, they select that nearest neighborhood. Once they select the nearest neighborhood, then they will see the majority. So for k is equal to 5, if I consider in this k, so in the 5 nearest neighborhood I will see the majority, and I can see the majority is the cat. So I can say this image is goes to the cat. Maybe this image is a cat image, not a dog image, because dog is a minority here. So that what the intuition behind the KNN. So it calculates the distance of a query point from each point, then it find the closest neighbors, then do the majority what for your query point. I hope the intuition behind this algorithm is clear. Okay, now we're going to talk about what is a KNN. So KNN is supervised machine learning algorithm which can be used for the classification as well as the regression task. In the classification, it will do the majority what? That what I define in the intuition. But in case of a regression, once you define the nearest neighborhood, say you define the 10 NN, means you define the 10 nearest neighborhood. So it will take the mean of the 10 nearest neighborhood and assign to the query point. That what it will do in the regression problem. Why? Because in the regression problem our output is the continuous. So in the regression it work like that. So if you see up to here, the KNN is a non-parametric algorithm. We already studied in our video what is a non-parametric model. So why KNN is non-parametric? Because it does not assume any assumption of the underlying data distribution. It is not assuming the shape of a distribution, as well as it is not assuming what is the functional form of that function. So it is not assuming anything. That means it is a non-parametric method. And most important here, the KNN you can use for the non-linear data. Many algorithms in a machine learning like linear regression only work if data is a linearly separable. Logistic regression is work well if the data is linearly separable. But in case of KNN, if you have the nonlinear data, then also it work well compared to the others algorithm. But it have a lot of disadvantages as well. That one we will discuss one step by step. Now come to the next point. The KNN is a lazy learner. This is the one of the most important point to understand while studying this algorithm. So why KNN is lazy learner? Because if up to this time what we study, we need a training data, we need information to train our machine learning model. That means in every algorithm what we do, we have one training phase where we train our model, and then at the testing phase we do the prediction. But in the KNN and the training phase, we are storing our values in a model. We not at all doing any training. That means we just in the training phase we just take all the data values and storing in the model. And in the testing phase, once the testing phase come, once the new query point q come, then you will calculate the distance of this query point from every point which you store in the training phase. Once you calculate the distance, then you based on the k value, based on the nearest neighborhood, you do the majority vote. That means your training is very faster in the case of the KNN compared to other algorithm. Why? Because in training phase we are nothing doing, we just storing the values. While in the testing phase it takes too much time, it consume more time, because it need to scan all the values, then it need more memory to store all the values, it need more space to store all the values. So our testing become the worst in the KNN, while the training is very faster. But in other algorithm, we train our model to predict in a testing phase. But so that's due to this reason, we can say the KNN is lazy learner. Okay, so this is what about the KNN algorithm. Now, if I talk what is the maths behind the k nearest neighborhood, to whatever we have discussed in this video, distance is only the one of the most important concept to make KNN work successfully. So we have a lot of distance metrics. Based on the problem, you need to choose which distance metric you're going to be considered to calculate the distance between the points, your query point, and your the data set. So so there are the some few common distance metric which generally we use, that what we are going to see in this video. So first stage come where we study the Minkowski distance. So Minkowski distance, it can be calculated in the normed vector space. That means the distance can be represented as a vector that has a length, and length cannot be a negative. So if you see this formula here, if you see this formula here, how we calculate, we take the summation, then we take the absolute value of the Cartesian points, then we do the p square root. So it is calculating, it is a normed vector space. That means here everything we are treating as a vector. Okay, now this p value is very important here, because if p is equal to 1, we will get the Manhattan distance, and if p is equal to 2, we will get the Euclidean distance. So what is the Manhattan distance? It can be calculated based on the square box, like from one point to another point there should be an angle of a 90 degree. So if you keep the p is equal to 1, then this part will become the 1 and this part will become the 1. So our distance formula reduced to the summation of absolute value of 2 points. So distance between the 2 points is the sum of the absolute difference of their Cartesian product. This is the Manhattan distance. If we go forward, when p equal to 2, we will get the Euclidean distance. So Euclidean distance, with that what we are studying from our school to this time, what is the Euclidean distance? A square root of summation of xi minus yi whole square. It measures the distance between 2 points in the Euclidean space. Okay. So mean cos k distance have a two type of a distance. One is the Manhattan and one is the Euclidean. Based on your problems, it is much more important to know which distance metric you're going to be used to calculate the distance between the points. Okay. Moving forward, this is one of the most important and very useful distance metric known as the cosine similarity. It calculates the similarity between two vectors and determine whether two vectors are pointing in the same direction or in the opposite direction. So suppose we have a two vector, one is a A and one is a B. We can calculate the cos theta. Cos theta is equal to A dot B divided by magnitude of A and magnitude of A and magnitude of B. Once we calculate the cos theta, we will get the similarity between two vectors. But our interest to know what is the distance. So how you can get the distance? You have to be subtract from 1. That is the 1 minus cos theta. You will get your distance metric. Cosine similarity is very useful metric in the natural language problems in the machine learning or in the deep learning. Say we use cosine similarity to calculate what is the distance of your currently watching video and to the video which the channel is going to be recommend you. So in the recommendation system or in the question answering system, this metric is very useful. And how to calculate the similarity between two text. This cosine similarity is one of the most important metric which we use generally in our NLP problems. Okay. One distance metric is known as the Jaccard similarity, and that is also very similar to cosine similarity. But these kind of a distance mostly we use in while implementing the KNN. But it will depend what problem you're going to be solve with respect to the while applying the KNN algorithm in your project. Okay, moving forward, the most important concept come here. How you going to decide the k in the nearest neighborhood? And your k is an integer. So how you going to be decide that what is your k value in your nearest neighborhood? How you going to be choose? So let's understand about it. Let us suppose we have the data which is distributed in this manner. We have this p is a query point. So how I am going to decide the value of k? K is an integer. K is an integer we have. So how I going to decide? So let's start from 1. Let us start from the 1. Say k is equal to 1. So in case of k is equal to 1, what it going to do? It will calculate the distance of p from every point. Then based on the one nearest neighborhood, that is the one nearest neighborhood is star. This point it will do the majority what. Here no need to do majority what because we have only the one class, so it will take p is this class. So in case of the one nearest neighborhood, you will get your training error very high, say 100%, because so your algorithm tried very hard to know okay star is the label of this p point. But what happened when I pass the unseen data to it? What happen if this star is not there? In that case your test error will be very low. So what is happening here? Your training error is very high, your test error is very low. That means your model is overfitting to the data. Overfitting to the data. Because your model trying hard to find one nearest neighborhood which is not be the case in testing data. In this kind of a model, you have high variance plus low bias. That's what you not want. That's what we have discussed already in the last video. So in place of k is equal to 1, say I increase the value k is equal to 30 nearest neighborhood. So if 30 nearest neighborhood, so 30 nearest neighborhood means all the points less than 30, you are considering more the value. So your data, your model is not at all doing anything with respect to your data to find any pattern, to find any nearest neighborhood, to do majority what. Your model not doing anything, not learning anything even in the from the training as well as in the testing. That means both the error is very high. That means what, your model is underfitting. Your model is underfitting to data because it does not learn anything. So if you increase the value of k too high, your model will underfit. If you take k values very low, your model is overfit. So once it is underfit means it have the low variance plus high biasness. So we can't increase the value of k too high and we can't decrease the k too low. So that means we need to do here trade-off between bias and variance to know the value of k. Okay, so if we do the trade-off between the bias and variance, we have the optimum value of the k which can give us the minimum error. That what, and how we going to be choose, there are the lot of methods. Say cross validation, we can do the cross validation, we can do the k-fold cross validation. There are the many things are there which are helpful to decide what is the value of k. So this is what about the KNN algorithm. This is one of the simplest algorithm in a machine learning model. Before finishing the video, let's discuss what is the advantage and disadvantage of the KNN. So if I talk about the advantage, we can be used with the nonlinear data. That's what we have discussed. In training is much more faster compared to other algorithms. It is very simple to implement. Then what are the disadvantages? Computation cost is very high. We need more storage space. Okay, it does not work well with a large data set and it is sensitive to noise and the missing data. Now one of the most important concept is left here. I am always choosing the value k as odd value. Why I am not choosing the even value? So this question we give the answer, then finish the video. If I give the k is even value, then I have the, say k is equal to 2. So I have one this and one have this. Then this query point goes to which? It is the 50%. I can't do their majority what. If I take k is equal to 4, then cross 0 0. So again 50%. I want to do majority what, so that I am taking k is equal to 3. Either this case will be there or this case will be there. Here I can do the majority what. So that's what about the KNN, and this much is enough to understand what is a KNN. I hope you understand this video. If you like this video, then please like, share and subscribe to my YouTube channel for more videos. Let's meet you in the next video with a new topic. And if somebody is following the ISLR book, this is the good news. We almost covered chapter 2 from the ISLR book. And the next videos we're going to discuss about the exercise questions. And thanks a lot for watching this video. I'll meet you soon in the next video. Thanks. Bye bye.